Hello, everyone. Thank you for your time to joining into these sections. So these sections is about cloud native applications on VMware Tanzu running on Azure. So my name is Hin Lam. I work for VMware. I'm the advisory platform architect. I belongs to a team called Application Platform Architect, and we take care about customer in the APJ, Asia Pacific, including Japan. Myself is based in Hong Kong. So I was ex-Pivotal, which got acquired by VMware 2 years ago. And then I was also ex-AWS. So I know a little bit about cloud. And in the slide, you can see I've got some blog posts. I've got some technology posts about that. Feel free to take a look. So without further ado, let's jump into the agenda. So today we are going to talk about two main aspects of cloud native apps. So first of all is if you want to write cloud native apps or you want to transform your apps into cloud native. So the question is why? And obviously we want to deliver business features into productions much quicker with greater velocity. But then how do we do it? So this is the first agenda. The second one is, hey, your application is now working in a great shape of modern applications. It is cloud native now. How do we leverage the modern cloud technology to run your application in at a scale with stability? And unfortunately, we only have 30 minutes to cover, so I won't go too deep, but at a high level, you should be able to identify what are the technologies, what are the methodologies, and what are the KPI that you can measure against your current portfolio. So how do you modernize your applications from monolithic to cloud native application? So here are some why you have to ask it first. And if you want to run cloud native applications, of course, you want to bring your ideas to market a lot faster and respond sooner to customer demand. It means that your current monolithic app may not be able to satisfy your need. So to unlock that complexity, cloud native, of course, is one of the way that you can build and run your applications that leverage cloud computing resources. So if you want to transform your apps into cloud native apps, the first question to ask is what exactly you want to do with cloud native, why you want to do cloud native applications and architecture. Because cloud native is structuring a lot of technology and your team. So the business reason is very simple. If you want to use cloud native, it could help you to transform your applications and help you deliver business value quicker and sooner to the market and to the productions. So why after we know why we want to do cloud native is to accelerate your business functions and features and helps you to gather more customer demand. So after we understand the why behind cloud native app and cloud native architecture, how do you measure your application transform? What does it mean by cloud native apps? Typically, there is de facto standard in the industry called 12-factor apps. That if your apps is written in a way that has many factors, like writing the log to standard out, is a stateless app, it has pop binding, which all these factors I will go in deep in the next slide, then you are taking a lot of advantages to design your application to run as a cloud native. And then if your applications is able to leverage the horizontal scalability of the cloud rather than taking up a bigger box every time you want to serve more requests, which is what we call scale up, then you actually enjoying the scalability of the cloud. And obviously, even public cloud like Azure is very stable, is very highly available, but the applications should also be designed to handle self-healing. to continuous working, even though the underlay infrastructure or architecture has some faulty component that is happening, and your app can present a still functioning, working service to your end user. And of course, if you want to be cloud native, you don't want to communicate between different services using like text file, like complex database structure, but instead, your application should be developed in a way that is API first and API driven, so that when one component can talk to another component, or one service talk to another service, they can use API to talk together rather than through intermediate legacy channel. And of course, there is some study saying that if you have monolith, even though monolith can be redesigned to satisfy the 12 factor applications, but it will be even better to use methodologies such as domain-driven design to break the monolith into different microservices so that they are well designed to function as their designed context, and you can scale out your team, your deployment, your velocity, and distribute your team into different microservices to accelerate features to production. So that's why given if you want to measure how cloud native you are, one way to say is how well designed your microservices and their interaction are. I just mentioned in previous slide, if your applications is running in using cloud native methodology, then your application should also adhere to 12 factor methodology as much as possible. I'm not going through every single factor, but as you can see, there are a lot of like common sense in this era that for example, you have to check in your source code to source code control. For example, you should expose your application using port binding, such as port binding um, with a talking to using HTTP, talking to other system using message queue. So all these port binding practices that helps you to transform your monolithic application into more 12 factor and therefore more cloud native. And obviously there is like something called build, release, and run, separations of build and release and run. Things like common sense, like don't troubleshoot and change the code at the same time in production environment. Strictly walk through all the build, release, and run using the CI/CD pipeline. So all these 12-factor apps are some measure to let you know if you have an application, maybe a monolith, you want to transform it towards more cloud native, then the journey is 12-factor is one of the checkpoint you are suggest to hit. So this de facto standard helps a lot of company transform their applications into a lot of more manageable size, and therefore at the end of it, they are able to break it down into microservices and become more cloud native and use the cloud native architecture. So by now on, you know the application has been transformed into more cloud native and more 12-factor applications. But when you do distributions of the app and you want to go to the productions of the applications, you don't want to distribute hundreds of individual artifacts, but instead you want to package it in as a container so that you can run everywhere, so that you can run independent of the host OS itself. You want to you are having more flexibility and you have more solid handover for the applications team and operations team to run it in production. So here are a list of the benefit, like why using container is beneficial. It's like you have a very consistent like delivery model. The artifact you deliver is image itself. It doesn't matter whether the apps is Java apps, Node.js, .NET apps. You just hand over the container image. And obviously, you also have better isolations. For example, you can run concurrently one different versions of Java apps or .NET Core apps concurrently in the same virtual machines, and they will be isolated by the Kubernetes or the container runtime, so that you don't have the limitations of versioning or security can be done individually. Like the CVE patches can be done in container A, while container B may be scheduled for another time to do. So that's why container are a lot of foundational building block for modern app. Okay, so now you understand the benefit of a container, right? The container image, if you have a lot of like microservices, you actually want a repeatable build every time when you update your applications. You want to generate same similar set of container image, and because of container image itself could be very flexible, you can include a lot of various component with various versions. So for example, if you write Java applications, right? I know you write 12-factor apps. I know you design it for cloud native, but every time when there is a security update for the JVM itself or for the base OS itself, then you will have complexity in tracking the changes there and here. So that's why in VMware, we have a product called Tanzu build surface, which leverage the cloud native build pack, which is shown on the slide that you can see. It can help you to build repeatable a container image according to what you want the version name, what you want about the stack OS, what you want about the JVM versions, and that allows you to build a container image in a fast but also secure way, so that when your container image want to run on like public cloud like Azure, or you want to run on Tanzu Kubernetes script, which is a Kubernetes distributions, then you can reuse the same image running in different environment and different locations for you. And therefore, we move you from a lot of complexity in manage plain Docker file, and also the versioning and dependency of your applications. So now you know how to build repeatable container image. We also have to consider not just container itself, but all the surrounding ecosystem. Say, for example, if you write your applications, you don't want to write from zero, from scratch, about a framework that support cloud native. You could reuse existing cloud native framework such as Spring framework. Using the Spring Boot framework could help you faster develop a cloud native apps. And also we use like .NET core libraries such as a Stuto that help. These are the library that helps you to develop your app in a cloud native way. And obviously, even though we suggest industry de facto standard suggests as a 12-factor apps, you should save your application state not locally but externally, and therefore you have to find a place to store your data. So a cloud native data service should be used so that you could leverage the benefit of the cloud. Say on demand database from Azure, like database like Cosmos DB, database like MySQL, or in-memory database like Redis provided by Azure Cloud, so that when your microservices has such a requirement, you can always spawn up a new database to run your applications from version to versions. And obviously, if you run distributed architecture, like if your microservices call each other, um, you have an observability operation requirement that you have to observe the interaction between different microservices and interaction between like from a HTTP request from the customer to the database. So in VMware, we actually have a product called Tanzu Observability that allows us you to observe from the infrastructure level integrated with Azure Cloud to your applications container, to like a Tanzu Kubernetes script as a Kubernetes running your container, uh, and also can be in deep as the application running inside the container for you. So if you run container, maybe you are running also multi-cloud. No matter that's like a different region in like Azure, or no matter this is different cluster, so that you can have segregations of different component. You still need some management for all these complex multi-cloud, multi-site, multi-cluster. So that's why in VMware we have a product called Tanzu Mission Control that helped you to manage different various copy of Kubernetes cluster in different cloud and in different sites within Azure or on-prem. So with all these super quick introductions to like what is a trail factor apps, why do you need container, how do you build container image, and all the surrounding things, you now understand, hey, if you want to call yourself, whether your app has been transformed to cloud native architecture or cloud native apps, then you know all these metrics. But how do you actually measure that? So that is a well-written book called Accelerate. So this book has listed out 4 KPI. So these 2 KPI is category in 2 areas. It's like throughput and stability. And and for sure, you now know that if you have transformed your app into cloud native apps running in a cloud native architecture, then you should have a high throughput and a very good stability. And therefore, you should have a high frequency of deployment. You should have a low lead time for change. And for all those change, it should be lower failure rate. But if you cannot avoid failure, uh, at all, then you are measured against the time to recovery. Like, hey, if I push a change to productions, but in reality, it doesn't work, then you have a very quick time to recover. So that also helps you to have a high stability. So that's why you can see in the slide, the spoiler alert is you can actually do high throughput and high stability if you are having a cloud native architecture, cloud native apps. All right, so it is totally understandable that if your apps is moving very fast throughput, even though it's very stable, but it at the end of the day it has to run in infrastructure, right? So in VMware, we have a Kubernetes distribution that I mentioned several times in previous slide. Sorry about that. I didn't introduce that. We have a product called Tanzu Kubernetes Grid. So TKG. So Tanzu Kubernetes Grid actually runs on-prem and also on cloud. And obviously, Kubernetes Grid, Tanzu Kubernetes Grid at its core is a Kubernetes that runs your container image, that runs your applications. So for Tanzu Kubernetes Grid, it is, if you want to have a very high rate of change in your delivery pipeline. So think about it when you're having an application want to deliver to productions, right? um, at the delivery part, if you deploy to the productions, you actually have to ask the operation team or infrastructure team to do change for you, whether it is like deploying new versions, whether it is like changing the load balancer. So all these operations actually very time consuming, and therefore there was a study from the previous slide. There is a book like Accelerate actually mentioned that if you leverage cloud computing, you can actually enjoy the benefit of all these rapid plays that align with your application. So for example, if your application want to provision event hub service in Azure, uh, you can always provision it on demand in Azure Cloud. That really shorten the chain of delivery for your infrastructure team. You are the user for the infrastructure that helps to deliver features to production. And then cloud computing also have a lot of benefit, like always on network access. It also allows us you to run multi-tenancies. Like if you have different project or different component, you want to subdivide it into different area in the cloud, you can always use the virtual private cloud features in Azure Cloud. to segregate resources. And also, if your applications is very dynamic, say it has a peak traffic, dynamic traffics, then you can always leverage the elasticity. You can always ask Tanzu Kubernetes, hey, I want more VMs from Azure. And Azure will provide more VMs so that the Tanzu Kubernetes script, the Kubernetes will have a lot more worker node to run your container instance inside the Kubernetes itself. And then obviously, you could like have resources metering, like if you have on-demand job or batch processing, you can tell Tanzu Kubernetes to run at particular time and do the scaling of the VM for you accordingly, so that you can save a lot of costs while maintaining a lot of growth, headroom to growth to handle the peak traffic. So in short, we if you want to run cloud native applications and design cloud native architecture, you can subdivide your life cycle of the applications into three life cycle. The first one is to build, right? The first one, when you build your application, you follow the cloud native 12 factor apps. You use the already well-defined framework like .NET Core, like Spring framework. You can create a container image using Tanzu build service, reusable OCI image, and then you can publish it to a catalog to use that. And then to run it, you can deploy a Tanzu Kubernetes script onto cloud environment such as Azure cloud, which leverage the elasticity and utility model of Azure cloud. And then meanwhile, you can always use something called Open Service Broker API to channel, to broker, to create, to manage all these great service provided by Azure, such as Cosmos DB, such as the Bob storage, such as the event-driven architecture that you can leverage using Azure. You can write a cloud native application running in Tanzu Kubernetes script that communicate with Event Hub, so that you can have a event-driven architecture running awesomely in Azure Cloud. And then last but not least, you still have to manage the life cycle and monitoring of these moving parts, like Azure Cloud itself, resources utilizations, Tanzu Kubernetes grid. The Tanzu is the Kubernetes itself, the application running in Kubernetes. So that's why we have a management phrase, that we have a governing what I mentioned is like Tanzu mission control governing multi-cluster, multi-sites. And then you have something like observability, and also some toolings about a product that we have about surface meshing between different microservices. So in that sense, in that way, you can run your cloud native applications using Kubernetes as a unified way to run on multi-cloud and multi-region and multi-cluster on top of the great Azure cloud ecosystem. With that, thank you very much for your time to join in these very short sections to let you know how cloud native applications should be. How do you measure that? What are the elements for cloud native application and architecture? How do you measure that? And the benefit of using cloud computing with your cloud native applications. And also for VMware, we have plenty of products that can help you to run multi-cloud, multi-cluster, multi-site applications, cloud native applications on the awesome cloud of Azure. So thank you. With that, I will hand over to the next sections. And if you want to contact me, the contact information is already on the slide. And feel free to ask any questions in the question box. So thank you.